I wanted to start out by asking you, what brought you to Stanford? You had a highly successful career, elsewhere, and we were so excited to bring you here a few years ago. What brought you here, and really what's kept you at Stanford?
Thanks, Josh. I really want to thank you for inviting me. What brought me really was just the fantastic just the sense of innovation, excitement at so many levels that I saw at Stanford. Whenever I met Paul, Wong, other members of the EP group, Alan, David, others from cardiology, I always got the sense that this is where it was at, that there was really the excellence at so many levels that all intertwined. So there was obviously the clinical aspect that was the underlying thread. But then the idea was, how can we better understand disease mechanisms? How can we better leverage bioengineering? How can we better test tools or solutions in the clinic through trials? And then how can we train? And all of those things together were just a fantastic mix. Then I came and I got an office next to you and the deal was done.
So one of the things that we like to tout when the fellows come here to interview is the close proximity of the medical school to the undergraduate campus. We're right next to the schools for electrical engineering and genetics, et cetera. What kind of role has that played for you and allowed you to do the things that you want to do research?
That's a really good point. The campus is so accessible. Everyone's biking around. Some people are rollerblading. And I really have used a bit of that, not the rollerblading. But, we collaborate very closely with some machine learning, computer science people on campus, Mate Zahara, Peter Bayliss. We've worked with bioengineering. I work with Joe Wu, CBI, and Sean, yourself. I think that it's just fantastic that everybody is so close by. But more importantly than closeness, which is important, is that the collegiality is really sort of difficult to describe. I think you'd probably agree. I mean, I think most people I've spoken to do that. It's sort of rare to find a place where people are pushing hard and yet really open to new ideas, love collaborating. There's always a curiosity. When you suggest a project, whether it's CS or bioengineering or within medicine, I've never had anyone say that's a really dumb idea. I've never had anyone say, no, I just don't have time to meet you now. And that's not just true for me, but true for our fellows who've gone over, residents, interns. And I think that just makes it so much fun to work here.
Why don't you talk a little bit about the EP group itself, the broader landscape of EP at Stanford, and what is attracting our general fellows to that fellowship program?
Yeah, so I think we're very lucky to be led by Paul and have such a dynamic group. When I came, I think I was one of 4 or 5 attendings. Now we're up to about 9. And I think what's fantastic is how unique each of us are, and yet how well, again, we work together very collegially. If you look clinically and then from research, there's many different facets that I don't think you see at many programs. We've got people who came into the group who were trained essentially at all corners of the planet. And so that means there's not just one mindset. You've got people like Nitish, who's phenomenal and trained in VT and went to South America to learn techniques of epicardial access. Then, of course, UCSF for a lot of his training. Myself, England and WashU. Then Paul was a Brigham guy who came. It's just so diverse. And I think when you look at clinical, large animal research, learning from that, genetics through Marco, digital health through Mintu, everybody has a unique and strong footprint. And it's not often that you see that. I think you look at other programs, it's often one thread that no matter how successful they are, it's often sort of a unidirectional or bidirectional focus. And I think we are very diverse and hopefully excellent in many of those directions. It's fun. Clinically, we get on well and we do a broad number of cases.
The EP group, like many groups, was somewhat constrained by the volume that we could accommodate. And now we have this brand new hospital sitting here. Maybe you can speak to, how that's changing your clinical practice and the kind of research that you can do.
Yeah, so, my lab is basically focused on bioengineering applied to detailed clinical studies. And the facilities are truly state of the art. I actually thought they were really good at Pasteur as well. I sort of liked the architecture. The lab was great. The new facilities are tremendous. They're not far away. The staff are great and very research minded. I try to enroll essentially all of my ablations into a research study, and we're probably at about 90% consent rate. I have a couple of NH studies, and then we've got funding by other mechanisms. And I think it's great that the fellows are exposed to that. Each of them that have worked with me have led a couple of projects. They've almost all got abstracts, papers, and many have got grants. And again, when I say that clinical and research and innovation are in the DNA of Stanford, I really think AP is a great example of that, where all of us really intertwine those things.
One of the fellows that we graduated this year was a great fellow, general fellow, will be coming into electrophysiology, was mentored by you, AJ Rogers, part of our translational investigator short tracking pathway. And you did a great job mentoring him. Maybe you can speak a little bit about your philosophy of mentorship. I know he went to at least 6 countries, it seems like, to give international talks. So talk to us a little bit about what you like to do as a mentor.
Sure. Well, the most important thing is getting as many air miles as possible.
Right.
So I mean, he gets an A plus for that. But
Exactly.
but I think the key really is that I was very lucky to have just terrific mentors, and it's just the people you work with that change everything, don't you think? I know in your case, Tom Quatermos and
Yeah.
others, and in my life, I had Michael Caine, Joe Smith, just great people in England who I trained with. I want to give a little bit of that, if I can, by just trying to foster that sort of curiosity. Why is it this medicine or this ablation doesn't work? And so AJ was a great example of that. He happened to come with a bioengineering background. I've mentored fellows who don't actually. Tina, a few years before, did not. She got a K award, very successful, doing very well now on faculty. But I think the key is just to keep asking questions and realize how much you can do, in my opinion, from a clinical foundation. One often thinks you have to go basic, and of course, many of our faculty have, Marco among others. But I think there's just tremendous scope for fellows to take the idea and run. David Yang recently did that tremendous AI paper that you discussed that was published in Nature. It's remarkable. And again, through collaborations and through the idea that, no idea is a crazy one, and we're always here to support you. And I've tried to do that, and I know you do as well. Again, I just think we have a great division for that.
You bring good questions to the table. Maybe you can tell us a little bit about what you're doing in the lab now and what you hope to be doing over the next few years.
Thanks. That's very kind of you. So there's so many unknowns in electrophysiology. We just don't know what we're doing. We have a basis, which is good. So we're not completely flailing. But my focus is atrial fibrillation. And of course, ablation works quite well. I'd like to think we should be further along. And to me, it comes down to mechanisms. As you say, there are many ways to tackle any problem. And for me, it's how can we bring basic science to the bedside? And we've always tried to do that. In AF in particular, the feeling has been this is a chaotic, random process. I was actually taught that at medical school. I'm not sure if you were, but a lot of people still are.
Yeah.
And I think if you look at it at any level, it really isn't. It's disordered, but it's not random. It's not chaotic in the mathematical sense. So then the question is, what are the determining laws for it? Or, what are the vectors of influence? And we, through looking at this back actually about 15 years ago, we seized upon this basic science from Pepe Jalife and others that there were small driving centers that could be focal drivers or small rotational circuits, a bit like the center of a spinning wheel or the vortex of a storm, a tornado, that could be driving the chaos. They hadn't been shown before, so my first grant was actually funded, and it was rotors do not exist in atrial. No one believes me, but that was the
Ironic
first.
enough, yeah.
I know. So obviously we showed that we believe they are. And there's a lot of back and forth. I kind of, at some levels, I really love the controversy. It's been fun. And now, while we haven't yet proven it in randomized trials that ablating these things helps, I think we're getting closer and closer to understanding which patients they're present in. I think most people would agree they're present in some. Many people are looking at these with different approaches, and we're trying to improve ablation to find this. Ultimately, if we can find patients in whom there are drivers and those in whom there are not, we can then look back and say, what are the structural elements of the patients with and without? What are the genetic profiles with and without? And hence phenotype people much more richly than we currently do, and then end up truly with personalized therapy.
What do you like about being in the Bay Area? And specifically, maybe you could touch on about the entrepreneurial nature of the Bay Area and the proximity to Stanford have you found useful?
You know this, Josh. There's just such a vibrant atmosphere here. I mean, we're so lucky in so many ways. You've got grand rounds by people that formed iRhythm, Uday Kumar, people that did the Parmaschat stent. They came. And then of course there's the biodesign program that formally teaches how to write patents. I think it's a requirement for your first semester project. You
Yeah, yeah,
but just the idea that the reason I really love that concept is you could have the best cell therapy, genetic therapy, pharmaceutical, software device, mapping, or leg prosthesis. But if you're the only one doing it in your lab, it isn't going to change the world. You have to at some point translate that to wider use. And that's where the innovation, and I think at some level, the commercialization has to be part of it. And I think I love the idea that Stanford really catalyzes pushing that forward from the investigator. A lot of institutions do not. I think Stanford has reached a good balance where the investigation, which of course NIH funding is massive here, but works and coexists very comfortably with translating that. All the firewalls are in place. And you can see so many therapies that came from Stanford. I mentioned a couple in EP.
yeah.
And it's very real, for anyone that would look at the program, it's a very fertile place.
What specific role and what do you enjoy about interacting with the general fellows, the fellows before they've decided to do EP, the ones you're trying to convince to do EP? What role do they play in the EP community here?
So remember, air miles.
Right. I like that. Yeah. Hawaii. Yeah, exactly.
No, so I think that I really, we're here for a reason. We self-select. We love working with fellows. I mean, I think but I think the reason I do is it's just great to work with young, people who are excited and who are sort of bringing. Sometimes we've had a bit bad day or week. We can get a bit jaded. It's great to be rejuvenated by that, to ask questions on things we thought we understood and then we realized we didn't quite understand it. Then obviously they help a lot. I mean, obviously there's tremendous amount of work that's done that couldn't be done without the whole team. And I think just injecting that excitement. I mean, we've been lucky. I had a NIH K24 for, I renewed. So that helped me to actually carve out some time to teach the fellows. I mean, I wish we could do it better. I think we do a good job, but I think that is a key element. And beyond the fellowship, sort of launching the first 5 years of someone's career, that
Yeah.
pipeline, you and I have discussed this before. I think it's so important because again, it's who you meet, who inspires you, and how you're nurtured that defines everything. We've known people that were brilliant, that made the right decision, or few that didn't. And I think being guided in a very personal way by people that actually have the time to care about you is key. And I hope that we can do that.
Is there anything that you'd like to say that I haven't asked you?
No, I just think, particularly fellows who are looking at the program, I think it's easy to put Stanford as just another good program. Obviously, I didn't touch on the Bay Area stuff. Obviously, what's there not to like about living here?
Yeah.
But you go beyond that. I really mean it when I say it's a very special place. I've worked at lots of places. I've enjoyed them all actually, but there's something just really great about being at Stanford at this time, 2020. I mean, the way that everyone pulled together during lockdown, the way that, as you said, as fellowship director, you gave that lovely intro the week before, that no one batted an eyelid. No one skipped a beat. We went straight into Zoom clinical meetings. We immediately pivoted for the fellowship training. The didactics increased, in fact.
Mhm.
The clinical care, I think went very well. I just think it's such a special place where people pull together. And I really think it's the place where you're only limited by your imagination.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.